class. Okay, forget about the chat box. I don't think you need the chat box for now. Okay, if there I will audibly give you the particular instruction. Forget about the chat box. Okay, thank you. Right. Yeah, please see that there is no interrupt in the class, because when there is an interrupt, then again we have to go back and again we have to start from the beginning. Okay. Right, I hope you agree. Thank you. So again I am going to the first point. So register is nothing but a temporary storage device which is CPU, and the transfer of data is nothing but the data which is moved from one component to internal component to the other internal component. Don't think that from the keyboard to the screen or from the keyboard to the mouse or to the CPU. Internally some data is being transferred within the CPU, right? So here you can see on the screen, it starts from the memory to the cache memory to the registers. So what is cache memory? That we will come to know as we go on. Okay, right. The third one, CPU retrieves the required data from the registers and process the instructions. Right? As I told you last time. So you are retrieving the data. From where you are retrieving the data? You are retrieving from the registers. So register is nothing but a location in the memory. The location in the memory, right? Retrieve the required data whichever is necessary. When we want to execute any instruction at present, its required data should be there in the registers. I'll give you an example. You said C. In the next line you wrote D equals to 10. Now what happens? As we know, you get an error. D is not defined. So where is D? You have not defined D. You have not told the system to store a particular variable called D in any location. In such case, what happens? You get an error saying that the variable is not defined. Right? Hope it is clear. Right? So if you have any doubts or if you have any other problem, you can ping me after the class. Okay? Please concentrate on the screen, please. See there. Please view the diagram which is the CPU contains of ALU and control unit. We know that very well. Okay, in other we are having the registers MDR, MAR. Right? MDR and MAR. So memory address register. Memory in the memory we are having two types, there is MAR and MDR, right? So in that, what is PC? Program counter. What is IR? Instruction register. Okay, right? Okay, so you are having, see, memory dynamic register. So in the memory dynamic register, you are having number of registers like this: R0, R1, R2, R3, and so on till Rn. Okay, for every register, I will be having a memory address register again, right? Nothing but the value, the address, and next we will be having the program counter. So program counter is the initial stage of where you are starting your particular instruction, right? And again, instruction is nothing but where you are storing the instruction. Okay, so to make you understand, I will give you a general example. So you are all of second year. In second year, we are having almost 8 sections, 8 or 9 sections, whatever it may be. Every section contains attendance, or you take a single section only for every subject. For every subject, you will be having a different attendance register, and every attendance register initially you will be having a page where you start writing from when the particular class has been started, right? And as you move on with the pages, all the names of the students will be written sequentially, and parallel to it you are going to mark the attendance. I hope you all know very well, right? Now what I mean to say is, So this MDR is nothing but something like attendance register. Is the class. In this class, you are having number of registers. One register for COA, one register for DS, one register for C++. Plus like that, you are having number of attendance registers. In the same way, MDR has number of registers. These are memory. In every register, you are having something called as MAR. So a register is of which set? COA. So it has a particular name, that is memory address register. Next, program counter. So initial stage of where the particular instruction is going to start. And that I told you, right, the initial register not started. Now next IR should register where you are going to store all the data regarding that. Okay, and all these are connected to the main memory. As I told you already, registers are nothing but temporary locations. In the previous slide we have seen temporary locations. See, register is a temporary storage device. Okay. Yes. So what are the types of registers? Just now I was talking about. There exist different types of registers in the system. PC, MAR. We'll come to know what is it as we go into the subject. Okay. PC, MAR, IR, TR, OutR, INR, DR, and AC. So here the memory has a capacity of 409. Right, which hold these particular registers. So what are these? PC, what is this MAR? We will see. Yes. Now yes, I have got a yes. Is it clear now? I think now you are. చెప్పండి. ఏంటిది?
Your voice is talking, sir.
ఓకే నా వాయిస్ బ్రేక్ అవుతుందా?
Echo coming.
Echo coming. I am in a closed room. Fine, okay. I will do everything. Okay, I will try to move out. Okay. Okay. Yes. So computer registers are designated by capital letters. Right, when you are representing them, right? So first one is the MAR, as I told you, memory address register. So what is memory address register? We will see that as we get on it. Just try to concentrate what is there. Okay, register. Piece. I was telling in the previous slide, right? IR, instruction register. Okay, and so on till R. Process registers. So each and every process takes a R1, R2, R3 and so on. Okay. So to make you understand, I will give you again a simple example. How much memory? Question. Okay, in the chat box now, you can assume the answer in your answer. Right? How much memory do you have in your brain? Or how much part of the brain is allotted for the memory? Or how much memory do you teach you do in your daily life? Okay. So here, for this question, generally you may not get a proper answer. Okay. For this question, you may not get a proper answer. Why? Because the brain or the memory can be segmented in any parts. Right? The brain can be segmented into many parts. Like that, the memory can be segmented into many number of registers. So whatever we are discussing here, it is not that physically you can registers in the memory. It is everything is a logical partition only. It is just a logical partition only. Okay, right. So see that the basic symbols of transfer. So the letters are, the symbol is given like this. Letters. Okay, it denotes a register. A is a particular, or you are saying R1, R2, R3, R0. They are all represented as registers. Example MAR, R2, R1, and so on. Next one, parenthesis. They denote a part of a register. Okay, the parenthesis denotes a part of the register. See here, R2, 0 to 7, R2, L, like that. Okay, okay. Next one. That means R in sense the registers which contains location from 0 to 7. Right? Okay. Below arrow mark. It denote information. So you are saying R2, that means to R2.
Hello.
చెప్పండి.
Sir, can I continue? Sorry, students. Actually, there is a problem with my internet. I don't know what is the problem. So I stuck in the middle of this. So now I can able to continue. Sir will move the slides and I can deliver my lecture. Is it audible? Is my voice is audible? Hello? 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 Is my voice is audible? like our main memory, cache memory, registers, and so on. They all are temporary storage devices, right? So here, whenever we have different parts of your system, in those, heart of the computer is the central processing unit. Why? Because it is responsible to perform all the tasks given by the user. That means whenever a user gives an input, CPU has to process that input and it has to give the output, right? So next, and here your CPU is having different components, something like ALU, control unit. Along with these two, we have registers. So your CPU is mainly having three components: registers, ALU, and control unit. ALU is arithmetic logic unit, which is responsible for performing arithmetic operations. And we'll see what is a control unit in the next session. Next, registers. Different types of registers exist in the system. For example, they are program counter, memory address register, instruction register, temporary register, outer register, input register, data register, and the last one is accumulator. These are all the different types of registers present in your computer system. Now, here I am saying that register is a storage device. Storage device means it needs some memory space. Now, how much of memory space is required to hold these registers? That is 4096 by 16 bits of memory space. 4096 by 16 bits of memory space is required to hold the registers, right? Now we'll see the representation of a register or naming of a register. Generally, registers can be named by using the capital letters. One way of representing the registers or naming the registers is by using the capital letters. For example, if you have a register R, then you can simply name the register as R. If the register is something like a program counter, I'll simply use the capital letters P for program, C for counter. PC is the name of one register. MAR, capital M, capital A, capital R, or the if the size of a register is some 16 bits, then its range is from some 0 to 15. If it is of 32 bit size, then the range can be from 0 to 31. Right? Now, whenever you want to specify the size, you can include the lower order bit at the right side of the rectangular box, and you can include the higher order bit at the extreme left side of the rectangular box. On the top of the rectangular box, you can include, right? If you have a register of size 16 bits, then you can specify the lower order bit as 0 and the higher order bit as 15 just above that rectangular. That is another way of representing the registers diagrammatically. Another way is the individual bits of a register can be represented. Assume that you have a register of size 8 bits. That means 0. The range is from 0 to 7 bit. So each bit, 0th bit, first bit, second bit, like that, you can represent every single bit of a register specifically using the bit numbers from 0 to 7. 0, 1, 2, 3, 4 and 7. That is one way. And the last way of representing the register is you can also represent the part of a register. When do we use these parts of a register? For what we'll use this? All this we'll see in the further units. You no need to worry. In this unit we are just we'll just see what is a register and how to represent the register, how to transfer the data from registers to register, right? So here when you want to specify the part of a register, you can just include into lower part as well as the higher part, and at the same time you should include the size or the range of the lower part and the range of the higher part. If the register is of size 16 bits and if I am dividing it into two parts, one part range is from 0 to 7 bit, obviously the second field range will be from 8 to 15 bits. Next we'll see micro operation. Before that we should know what is an operation. Operation is something like a task to be performed. Assume that if I have given an instruction some a plus b, that means a plus b is the task to be performed. Now whenever your CPU, your system needs to execute any instruction, then what is required? It requires the data. If I want to execute the instruction a plus b, I require the data values of a as well as b. Right? Now, from where we'll get this data? From where we'll get this data? Generally, we'll get the data from the main memory. Sometimes we'll get the data from cache memory. Sometimes we'll get the data from the registers. Next. One second. Now what is an operation is, assume that if you are performing an instruction and if you are retrieving the data required to perform that instruction from the registers, then that operation is treated as a micro operation. If you are retrieving the values of a and b from the main memory, then you will not treat that as a micro operation. If you are retrieving the values of a and b to perform a plus b from the registers, then you can treat that as a micro operation, right? Then when you see the definition of micro operation, it is the operations are executed on the data where the data is stored. It is stored in the register. We'll call it as a micro operation, right? Now, so once an operation is performed, you need to store the result somewhere. So here the result of a micro operation is again stored in the same register or in another register. Assume that if the instruction is something like c equal to a plus b, you will perform the micro operation a plus b and you will store the result into an register, another register c. So if the instruction is something like a equal to a plus b, then you will perform the micro operation a plus b by retrieving the values of a and b from the register, and you will again replace the register value a with the value of the register a with a new value of a plus b. That is what micro operation is. Different examples for micro operations are shift, continue, load and so and so. What are the shift operation, continue operation? that we'll see later, right? These are the micro operations. Register language. What do you mean by a register transfer language? Registers are used for storing the data. Transfer language means when you want to transfer the data from one register to another register, then you will use this register transfer language, and this transfer of data from one register to another register is done by using a replacement operator. Generally the replacement operator is something like reverse arrow mark. An arrow mark looks like a hyphen followed by a greater than symbol. Reverse arrow mark is less than followed by a hyphen, right? That is using that replacement operator you can transfer the data, right? And when you are transferring the data from one register to another register, always the data transfer happens bit by bit. If your register is having some 16 bits, if R1 is having some 16 bits, and if you want to transfer R1's data into R2 data, total 16 bits of data cannot be transferred immediately to R2. First bit will be transferred to first bit of R2. First second bit of R1 is transferred to second bit of R2. Third bit of R1 is transferred to third bit of R2. Like this, until and unless all the bits of R1 are transferred to R2, this register transfer will happen. That means transfer always happens bit-wise. Bit to bit transfer will happen. That is register transfer language. And one more thing to be remembered is, I already told you that when you are representing the registers in diagrammatically, you can specify the range of the register, and the lower order bit is always specified at the rightmost end and the higher order bit is specified at the leftmost end. In the same way, when you want to specify the register transfer from one register to another register, you can specify something like R2 arrow R1, and always the register transfer happens from right hand side register to the left hand side register. If I write R2 reverse arrow mark followed by R1, then it means that right hand side we have a register R1, left hand side we have a register R2. That means R1's data is completely moved to R2. That is the way of representing a register transfer language. Next we will see register transfer. Using the control function. We have already seen that there are three main components in your CPU. One is the control unit, ALU. One is control unit, ALU, and the registers. Right? What is this control unit? So here, for what this control unit is responsible? This control unit is responsible when to perform the register transfer operation. When to transfer the data from one register to another register is decided by this control unit. This control unit is having a control variable. Control unit is having a control variable. Control unit is compared with if-then statement. If-then statement. That means, what do you mean by if-then statement? If one condition is satisfied, then following instructions will be executed. In the same way, if the generally this control variable is represented with a letter capital P, and this control variable is a boolean variable. That means it will have only two values, either 0 or 1. If the value of P is equal to 1, then register transfer will occur. If the value of P is equal to 0, then no register transfer will occur. Generally, it is represented as P colon R2 to R1. That means P colon means by default the value of P is equal to 1. Whenever P is equal to 1, then R1's content can be moved to the register R2. That is the use of this control function, right? So control function will send signals when to transfer the data. This control unit is having a boolean variable, control variable, which is boolean. That means it can hold only two values, either 0 or 1. Whenever the value is 1, transfer will occur. If it is 0, no transfer will occur. When you see this diagram, here we have a control circuit which is producing or which is giving a control variable P. And here I want to transfer the content of R1 to R2. When this R1 data is placed into or moved into R2, when this is moved here, whenever this P value is equivalent to 1, when control unit sends a signal, the load input of R2 is activated. Load input means R2 register is ready to be loaded with some content. Whenever the value of P is equal to 1, then load input will be activated. Immediately after that, content of R1 will be moved to content of R2. When you see it's a timing diagram, here we have different clock cycles. First clock cycle, second, third, so and so, right? Now initially the load input is 0. That means control circuit is not sending any signal, means no register transfer is there. Whenever register R1 wants to transfer some data to R2, then control circuit will send high signals. It will send high signals at 10th clock cycle. It will send high signals at 10th clock cycle. Right? Now, whenever it sends a high signal, that means the value of P is equivalent to 1. Load input will be activated, and in the immediate clock cycle, next at T plus 1th clock cycle, transfer will occur. The transfer will occur. Next, immediately, once this transfer is done, the load input will become 0, or it will be deactivated. Why? Because if it is high throughout all the clock cycle, if it is high, load input is high, means what? Value of P is equal to 1. When the value of P is equivalent to 1, then what we call register transfer will happen throughout all the clock cycle. But that should not be there. Once the content of R1 is placed into content of R2, then transfer can stop. That is the reason whenever at T plus 1th second register transfer will occur, immediately after that load input will become 0. Right? So when you are moving the content from R1 to R2, R1, whatever the data we have before this transfer in the register R2, everything will be replaced by content of R1. Whatever is there previously, that will be replaced with the new content of R2 in case of register transfer language. Right? There are different types of micro operations we have. One is register transfer micro operation. In this register transfer micro operation, we transfer the binary information from one register to the another register. Second type is arithmetic operation, arithmetic micro operation. Right? Here, arithmetic operations were performed on the numeric data which is stored in the registers. That is arithmetic micro operation, like addition, subtraction, multiplication, division. These are the arithmetic operations performed on the data which is numeric data, on the numeric data which is present in the register. Third one is logic micro operation. These perform bit manipulations on non-numeric data present in the register. We will see what are these arithmetic operations in the first unit only. In the third part of your first unit, we will have these arithmetic operations, shift operations, everything we will have. Just we should know what are the different types of micro operations we have. And the last one is shift micro operation. Shift micro operation is something like rearranging of the registered bits. Shifting means changing the position of the bit. So it performs shifting of the bits on the data stored in the register. This is what a register transfer language. I'll just brief what is this register transfer language is. Registers are nothing but the temporary storage devices. We have different temporary storage, different registers in our system. They are memory address register, program counter, accumulator, instruction register, and so on. To hold all these registers, how much memory space you require? 4096 by 16 bits of data is required. How do we represent the register? You can name the registers with the capital letters. And one more I forgot. You can also name the registers not only by using the capital letters. Sometimes you can use a combination of letters as well as numbers. You can also give the register name as R1, R2, Rn, R7. Like that, combination of letters and numbers is also used to represent or to name the register. And diagrammatically, if you want to represent the register, you will just use a rectangular box. And if you want to specify the size of the register, you can just mention the range above the rectangular box. Next is the register transfer language. So register transfer language will move the content from one register to another register so that the previous content will be erased and new content from the other register will be placed. Generally, it is represented using a replacement operator. How does a replacement operator looks like? It is reverse arrow mark. And the register transfer will happen from right hand register to the left hand register. And always the transfer happens bit by bit. Bit by bit transfer will happen. Next is using when do we perform this transfer? So here this control unit which is present in the control unit which is present in this what we call CPU is responsible for register transfer language. It contains a boolean variable, control variable, which is boolean. That means it will take only two values. If the value is 1, then only control transfer operation will happen. Transfer of data from one register to another register is happen. Right? If it is 0, no transfer will occur. Different types of micro operations are there. Are 4 types of micro operation that we'll see in the further classes. Shall I continue with the next topic, that is multiplexers? Let me know. Actually the allotted time is over, but here because of some problem here, today almost some 20 minutes were wasted, so I am thinking of continuing the class. Just let me know, shall I continue or not? The next topic is actually the next topic is common bus system, but but to understand the common bus system we need to understand what is a multiplexer. Actually you need to understand the multiplexers. Actually it is not there in your syllabus, but without this multiplexers you cannot understand what is what we call this common bus system. So multiplexers generally multiplexers sometimes we'll also in the short form you'll call them as MUX. MUX is multiplexer. The multiplexer is a digital circuit which has multiple inputs and a single output. Multiplexer is a digital circuit that has multiple inputs and a single output. Generally, what is the size of how many input lines will be there, and how many output lines? Number of output lines is always equal to 1 in the multiplexer. Why? Because in the definition itself I told you that this multiplexer has multiple inputs but the number of output lines are 1. That means n number of input lines will be given to the multiplexer. Among all the n number of input lines, which input line will become the output line? Which input function will be the output function? That is what this multiplexer is. And this is always decided by the selection lines. This is decided by the selection line. So your multiplexer generally contains the input lines, output line and a selection lines. Multiple input lines, single output line, and the number of selection lines always depends on the number of input lines. Assume that if the number of input lines are 2 power n, then the number of output lines are obviously 1. Irrespective of the number of input lines, always the number of output line is only 1. So if the number of input lines are 2 power n, then n selection lines will be there. N selection lines, number of selection lines are equivalent to 1. Just concentrate on this multiplexer topics. If you don't understand this multiplexer, you may not understand the further topics. Right? So just actually it is a easy subject, so try to concentrate on this. If you have any doubts, you can ask me later. Just first listen what I am teaching. Okay? So 2 power n are the input lines, 1 is the output line, then number of selection lines are n. For what these selection lines? Selection lines are used to decide which input line is to be selected to get the output function. Next slide. Okay. So different types of multiplexers. Next slide. Different types of multiplexers are 2 by 1 multiplexer, 4 by 1, 8 by 1 and 16 by 1 multiplexers. Right? Generally multiplexers, the size of the multiplexer is represented with input lines into output line. Always the output line is anyway it is 1. Only the figure of input line will be changed. If it is 2 by 1 marks, that means we have 2 input lines, single output line. 4 by 1, 4 input lines, 1 output line. 8 input lines, 1 output line. 16 input lines, 1 output line. Let us see. Go to the next slide. Next. So here we have a multiplexer which is of size 2 power n by n. That means we have 2 power n input lines and next slide and 1 output line. So whenever the input lines are 2 power n, then how many selection lines you will have? Whatever the power value it is, whatever the power we have, so 2 power n. So those number of selection lines will be there. So number of selection lines are always equivalent to 1. Right? This is a multiplexer is. Now we'll see the basic multiplexer, that is 2 by 1 multiplexer. Go to the next slide. 2 by 1 multiplexer. Okay. So here in this 2 by 1 multiplexer, obviously we'll have 2 input lines. Let us I have named them as D1 and D2. Whenever the input lines are 2, how many selection lines will have? 2, but 2 input lines means what? 2 power 1. What will be the power value? 2 power 1. Whatever there in the power, those many selection lines you will have. Right? So 2 power 1 means power value is 1. So there exists only one selection line. I have represented the selection line using the letter yes. So 2 inputs D1 and D0 and you have a 1 output Y and to the 0th port of the multiplexer, that will be chosen as a output, that will be selected for output. If the value of yes is equivalent to 1, then whichever the input is connected to the first port of the multiplexer, that will be chosen for the output. When you see this logic circuit diagram here I have used 2 AND gates. Why? Because how many inputs we have? We have 2 inputs, D0 and D1, and always the OR gate is equivalent to 1. Only one number of OR gate will be using. Why? Because the number of output lines is only 1. Right? Now when you see this logic diagram here, what is the first one? First AND gate is for D0 input, second AND gate is for D1 input. How do we get the output? When do we select the first input D0? Whenever the value of S is equal to 0, then whatever is connected to the 0th port of the multiplexer, that will be chosen. So the output will be written like this: Y equal to D0. D0 is selected when S equal to 0. Here you need to remember that whenever we'll write yes as it is if the value is 1, and if the value is 0, we'll just write this as S complement. S complement means above this yes we'll use one hyphen that represents S complement. Complement means if the value is 1, complement of 1 will be 0. If the value is 0, complement of 0 will be 1. Right? So we'll write the output as, I will select this input 0 whenever the value of S is 0. Whenever the value of S is 0. That is the reason I have used S complement, because I am taking S value as 1. Right? So this is your select line. Yes. Your select line is yes. Complement is represented using the NOT gate. How do we write this NOT gate? Some triangle with a knot at the end, with a circle, small circle at the end. Right? So yes, NOT gate represents S bar, that is complement of yes. Right? So D0 S bar, D0 S bar, or you will select the input D1 whenever the value of S is equal to 1. So I'll just take the select input as it is. So you can select D1 whenever the value of S is equal to 1. Right? These are the two possibilities we have. One possibility is you will select D0 when S equal to 0. You will select D1 when S equal to 1. Among these two possibilities, that means among these two inputs, you can choose only one input, because multiplexer will always give one output. So to get this output, how do we write? Using this OR gate. OR gate is when you write this OR gate function, OR gate is represented with a plus. Generally OR gate is used for summation, AND gate is used for production, that is for multiplication. For production we'll use AND gate. For summation we will use OR gate. Right? So Y is equal to D0 S bar or D1 yes. So based on the selection value you will choose D0 or D1. This is the basic multiplexer, which is 2x1 multiplexer. Once again, if you want, I'll send my PPT, or I'll also send my notes to you. First, you please refer this multiplexer once. If you don't understand, let me know. If possible, I'll again repeat in the next class, because I know that you may or may not, I don't know whether you understand this multiplexer or not. Anyway, I will again repeat 4x1 multiplexer in the next class, but you repeat this again in the at home. You refer these multiplexers at home. I'll send my PPTs. Right? You send me your CR's mail ID, so that we can forward the notes as well as PPTs, whatever is required for you. Right? I am ending my session today. If you have any doubts, you can just post in the chat box. Let me know whether anyone is having doubts. If you don't have any doubts, then I'll start this quiz session. Shall I start the quiz? Just post in the chat box. I thought of continuing 4x1 multiplexer today, but what happens is, if I continue the same both 2x1 as well as 4x1 today itself, you may get confused. Why? Because actually you don't have, I don't know whether you have knowledge on this basic gates, AND gates, OR gates or not. As it is ECE subject, so we are just using those AND gates just to understand the common bus system. You don't worry about this multiplexer. We'll be using in the bus system. Okay student, I am going to start the quiz and I'll give you 15 minutes of time, and the number of attempts are 2.